Hey everybody, it's Jimmy from the DIY and Digital, and today we're throwing Kato Turnouts with an Arduino. Welcome back everybody. First of all, if you haven't already, go ahead and hit that subscribe button, hit that like button, and hit that bell icon so that you don't miss any updates like this Arduino tutorial. So let's get right down to it. There are a lot of different Arduino model railroad videos out there, but I have never seen a full-blown video tutorial on Arduino control of a Kato turnout. So I did my research, I did some prototyping, and I worked out a way to throw Kato turnouts with an Arduino, and it's actually pretty simple. So here's what you'll need: an Arduino UNO, an Arduino L298P Motorshield, a breadboard, a 4-prong button, a 1K resistor, some prototyping wires, and a 12-volt power supply that you can adapt to hook into the Motorshield. Let's get started with the prototype build. First thing you're going to do is you're going to put the Motorshield on top of the Arduino. Remember, the pins line up, so they should all match. The next thing you're going to do is you're going to take the breadboard and place the button on it. Now there's a little strip of no rows right there in the middle, and you want the button to straddle that center point right there because we want to have each side isolated from one another. Next, we're going to do our power connections to the breadboard from the ground and 5-volt connections on the Arduino to the positive and negative strips. We're then going to connect the button to the power supply. It really doesn't matter which side you hook up so long as it's on one side or the other. Next, we're going to hook up power to run through our button so we can use it as a sensor. First thing you're going to do is you're going to hook up power to one side of the button on the breadboard. Then you're going to take a resistor on that same side and hook it up to the other connection. You're then going to run it from the resistor to the negative side of the power strip. Then on the opposite side of the breadboard, you're going to connect another prototyping wire and run it to the analog pin A0. This is going to be your sensor output for the button. The last thing we're going to do is we're going to hook up the adapter to the Motorshield power supply. Alright, let's head over to the computer. Okay everyone, we're in our Arduino IDE and it's time to do a little bit of coding. So the first thing we always do in our programming is we set up our integers. So we're going to do int turnout equals 12. Alright, so what this is basically the way that a Kato unitrack switch works is it's got a little magnet in it, and by changing the polarity of the magnet, you're going to be snapping this little bar back and forth, and that is transitioned into switching the switch back and forth. So we're going to say that this is the way we're going to change the polarity of the switch. So the next thing we're going to do is we're going to do int break equals 9. And this is basically just part of, we're essentially mimicking a DC motor from the Motorshield, and this is just part of the that's part of the DC motor program language. We're always going to pretty much have that low or off because we're not going to be really worrying about running an actual motor. Next thing we're going to do is we're going to do power equals 3. So this is the pulse width modulation pin, or PWM pin, of motor A in the Arduino Motorshield. So we're going to say that this is the power for the turnout. So this is basically where we're going to get the actual power of the charge that's going to reverse the polarity. The last integer we're going to do is button equals a 0. And this is just establishing our button input for throwing the switch. Okay, so now we can go ahead and go into our setup. And we're going to start off by doing all of the pin modes. We're going to establish the turnout as an output. And this just establishes pin 12 as an output. And we're going to do the same thing for the brake pin. Power pin. And you don't necessarily need to do this, but I'm going to go ahead and establish the button pin, or pin A0, as an input. Okay, so that's what we need to do in the setup, but before we go into the loop, we're going to do something that we have done before in our block signal. Now, this is not necessarily the simplest and easiest way to code this. You guys that are better with Arduino than I do probably can think of a simpler and easier way, but this way is completely foolproof. I have tried several different programs that have not been quite foolproof in terms of switching the switch properly every single time. So let's go ahead and we're going to enumerate switch states. We're going to do our little bracket. And we're going to do ST off 1, ST off 2, ST straight, and ST turn. And what this is doing is we're going to go ahead and say this establishes different states of the turnout program, and that'll make more sense when we get further down. Like I said, if you've done the block signal program or if you've seen that video, this already makes sense. Alright, so now we're going to do switch states. Switch state equals ST underscore off 1. And that sets default state to ST off 1. Okay, so that's everything that we need to write before we go into the loop. So let's go ahead and start our writing of the loop. So we're going to do void loop. Now we're going to do integer button read equals analog read button and this tells the program to read the button signal. And then we're just going to put a delay of 200 right there. And then we're going to say switch state. Alright, so now we are doing all of the different cases for the switch state. But first we're going to put a little bit of formatting in here. Okay, we're going to start off with case off 1. Then we're going to put a regular colon. Then we're going to do switch off 1, button, read, and then break. And what this does is just setting up our variables and for our different little loops within loops. So I'm going to go ahead and do all of these real quick and I'll come back and explain through. Next we're going to do case state off 2, switch off 2, button read, and break. And that sets up off 2. Then we need to do another case, state, straight, colon, switch, straight, establish that button read variable, or integer, I'm sorry. Then we need to do break, and last but not least, we need to do case state turn, switch turn, button read, break. Alright, so those are all of our different cases right there. So we can go in and start doing the individual loops now. So let's go ahead and do that. So we're going to start off with void switch off 1. And we're going to say that we need integer button read. We're going to start off by establishing the parameters of what switch off 1 are. So we're going to say digital write turnout high, okay, we're going to start off by setting up our default. Okay, so we're going to start off by setting up our default state for switch off 1. So we're going to go ahead and do digital write turnout low, digital write break low, and digital write power 0. Okay, so this part sets the polarity. This part releases the motor, and this part tells Arduino to not send any power. Okay, so now we need to get into the if-then statements. So we're going to go ahead and head down a little bit right here, and we're going to say if button read is greater than 500, switch state equals st_turn. So basically what that is saying that if the button reads over 500, which in this case is what it'll be when it's pressed, it's going to go to switch state turn. So that is it for void switch off 1. So now we need to do void switch turn. We're going to be using the same integer. We're going to be saying digital write turnout high and then we're going to say digital write break low, and then we're going to do digital write power 255. So 255 is the maximum power you can send in terms of the command from the Arduino. So that's why we're saying 255. So we're going to say and then we're going to put in a delay of 200 milliseconds. And then we're basically just going to repeat all of this. So I'm going to just copy paste it right there. Except we're going to change this to 0. Fix a few things right here. And then we're going to do switch state equals st_off2. And that's going to switch us to our second inactive state, or what we're calling off 2. So what we're doing here is we're setting our polarity to high, which sets it to one direction, and we're releasing the brake, and then we are also setting the power to max for 200 milliseconds, and then we're turning it back off. So just enough to snap that switch one direction and then turn it off so that we do not overheat the switch. So we're sending as minimal of power as possible to make sure that we do not overheat the switch. Okay, so off 2 looks very similar to off 1, so we're just going to copy and paste off 1, and then we're just going to make a few minor changes. So we're going to switch the switch off 1 to switch off 2. We're going to turn the turnout to high. We want to maintain the polarity so that it doesn't do anything weird. We only want it to shift polarity when power's going on. We're going to leave the brake alone, we're going to leave the power alone, and we're going to just change this to straight. And that should be all of the changes that we have to make. And switch straight is going to look like switch turn. So we're just going to copy and paste. And we're just going to do the changes. We're going to do switch straight. And we're going to change the turnout to low on both of these. And we're going to switch it back to off 1. Okay, so let's look at the changes that we've done here really quick. So switch off 2 is going to have the same polarity as switch turn, because we don't want it to risk changing anything and doing anything wonky and not throwing the switch properly. So there is high, high, and then we're going to come into switch straight, which is our switch back to the original position, and that's low, which means it's the opposite. So the polarity is going to reverse, which means that the magnet inside is going to pull the switch motor in the opposite direction, therefore throwing the switch back the other way. And then we're going to send it back to, and we're going to do that for 200 milliseconds, and then we're going to send it back to off 1 over here. So it's a continuous larger loop. So that's pretty much it for the programming of the Kato Unitrack Arduino control system. So we're going to go ahead and verify this really quick. And there we go, it works. So we'll go ahead and upload it and we'll head back over to the layout. So we're over here on my layout because I actually don't have any Kato Turnouts laying around. So we're going to have to use one that's actually on my layout. So we're going to take the 2 feeder wires that come out, one red and one black, and hook it into the A motor terminal of the Motorshield. The red wire goes into A positive and the black wire goes into A negative. We're now all hooked up, so we're going to go ahead and press the button, and voila, the switch throws. And you can see it going back and forth. Now notice the lights on the motor A terminal on the Motorshield, how they're going back and forth. That's kind of a representation of the polarity shifting that we are using. Okay, so that's really, really cool. But what if you want this to also act as a signal on your layout where you want this to be able to say, hey, the main line's clear, or hey, the main line, the switch isn't thrown correctly. So let's go ahead and do that. It's actually really, really simple. You're going to need 2 LEDs, one red and one green, a 1K resistor, and 3 more prototyping wires. We're going to go ahead and put the LEDs on the breadboard right here, and you got to remember that we're going to have a common positive, so the long pins on the LED need to be on the same row. We're then going to put the resistor on the common positive line. We're then going to hook up the green negative to digital pin 6, and the red negative to digital pin 7. We're then going to take a wire and hook it up to the 5-volt power supply strip that is on the breadboard. Now let's head back over to the computer to modify the code. Okay everybody, we are back in our code and we're just going to do a few quick modifications that will allow the signaling to occur when we have the turnouts thrown in different directions. So the first thing we need to do is we need to add a couple of extra integers. So we're going to do int green equals 6. We're going to say that green LED controlled by pin 6. Sorry, we'll say digital pin 6. And then we're going to do int red equals 7. Red LED controlled by digital pin 7. Alright, so that's everything we need to do in terms of our declarations. Next we need to step down into our setup, and we're just going to go pin mode, green, output, and that establishes pin 7 as output, and then we're going to do pin mode red output, and that establishes, sorry, I got that backwards right there. That's pin 6. You guys know I'm not very good at typing sometimes. As output. Okay, so that's everything we need to do in the setup. So the next thing we need to do is we need to scroll down to void switch off. So the first state, so switch off. So let's go ahead and go to switch off right here. Okay, so what we're going to do is we are going to say switch off needs to be green because it represents the straight and going through on the main line rather than going on the turnout. So we're going to do digital right, green, low, and that turns on green LED. Then digital right, red, high, turns off red LED. Okay, so if you remember when we did the Arduino block signal, we used a common positive setup, which is the most common one for various different signals that you're going to buy. So we have to use the separate ground connections, which means you're going to reverse your thinking a little bit, which means we're going to say green low means actually that the power is on to the green light, and then red high means that it's actually off to the red light. So if you haven't already watched that video, I'll link it right up here, but let's head on down to switch turn. So now we are in switch turn, and what we're going to do here is we're going to go to right here to the power, and the way I want this to work, and you can do this a little differently if you know how to do the slight alterations, they're pretty easy, but I'm going to go ahead and say that I want green high. That turns green LED off. And I also want red high as well. I want there to be a slight delay in the switching of the signals. I want it to be green, off, red, off, green. And it's just, it's a half a second or maybe even a second, not too much at all. And we're going to go ahead and copy and paste that. Right there, because we're going to still have it in that. And that literally lasts about 0.2 of a second. So it's not going to be much of a flash, it's going to be just enough. So now we're going to go to switch off 2, and rather than typing up everything all over again, I'm just going to go over here to switch off 1, and I'm going to copy it, and we're going to just paste it right there, and we're going to reverse them. So we're going to change green from low to high, and we're going to change red from high to low. And of course this means that it's turning on the red LED and turns off the green LED. Okay, so now the switch straight is basically the same as the switch turn, so all we need to do here is we'll just copy everything right here, and we'll just go ahead and copy paste. And that is all of the code changes that you need to make to enable signaling with the Arduino. So let's go ahead and head back over to the layout and give this a little test run. Now we have a train waiting to enter the main line here. Notice that the main is lit green, which means that the turnout is aligned for travel through it. So let's go ahead and push the button. Now watch as the light goes red, and the train can pass through the turnout. Once it's through, we throw the turnout back, and the light goes green. So that is how you control a Kato Turnout with an Arduino, and I'm really happy with the way this turned out. Now, I know that there are other types of switches, including snap switches and slow motion switches like tortoises or similar things. And I'm currently in the research phase of doing those. Those are slightly more complicated actually than the Kato Unitrack switch. So be on the lookout for those tutorials. And if you haven't already, go ahead and hit that subscribe button, hit that like button, and hit that bell icon so you don't miss any updates, including whenever I get the videos out for snap switches and slow motion turnout throws. Until next time, I'm Jimmy from the DIY and Digital. Happy railroading!